Hi, I'm Gilbert Strang. I teach at MIT, a wonderful job, and I get to teach you today about quadratics. So let me say, what is a quadratic? There's a ax squared. It's that squared that makes it a quadratic, and a b times an x, and a c, a constant. So that would be our, can I say, our function. If you give me an x, these a and b and c are numbers, and you'll see I'll change those numbers to get different quadratics. But this is the whole family of quadratics, and if you give me an x, then, and I know a and b and c, then I can figure out y. It's that squaring that makes the word quadratic come into this. Okay, so a good start is connect the algebra, these letters, to the graph, the picture, the geometry. So I've drawn 3 quadratics up there, 3 particular ones. Let me tell you what the a and the b and the c are. You see that those quadratics are just almost the same shape, just lifted up. So this first guy is going to be y is, I think I picked x squared minus 2x there for this one. Now this one is up a little higher. The c is what moves it up and down. That's the easy part. It doesn't change the shape, just shift it up. So I think that second guy is going to be x squared minus 2x, same thing, but plus a 1. So I've lifted it up by 1 to get the second one, and then the next one is lifted up by another 1. So the top guy is y is x squared minus 2x plus 2. Okay, so those are 3 particular quadratics. And what do I ask you about them? Let me start by asking, when is y 0? I'm looking for the x's that produce a 0 here. And I won't work right away with this general a and b and c. I'll work with these numbers, where a was 1, b was minus 2, and c changed from 0 to up to 1 and up to 2. So I'm looking to see, well, let me take the bottom one, the first one. So if I look, what points am I looking for? I'm looking for there's one point, and there's another point that I'm planning to figure out. That's, you could say, solve the quadratic. Find where it's 0. So I would like to find where this guy, that's the bottom one, is 0. Not too hard, but we will do it in a good way. So I want to find where that's 0. And maybe you know that one way to do it, if you have a nice example like that one, is factoring. If I can split this into, multiply 2 things together, and I can, do you know how I could factor that? An x appears both places, so I can like take out the x, and what's the remaining thing? That x squared, of course, means x times x, so I need an x times an x there. And here I have minus 2 times the x. That's what I would call factoring that polynomial. Quadratic, because it's got that square in it. Okay, and this tells me what I could probably figure out anyway, that it tells me where the zeros are. When is this 0? Well, this could be 0. That's this point. X equals 0. That's that point. Or x could be 2, and then this would go away. And if x was 2, I'd have 4 minus 4. I'd certainly get 0. And that's this point. So the 2 roots are, shall I introduce those words, roots? I don't know why we use the word roots. A lot of math words, you know. Who knows why? The roots are 0 and 2. Good. I have solved that first quadratic. Okay, ready for the second guy. this one. What do we see in the picture for that one? That's the middle one. And you see it's rather special. It touches the y equals 0. It hits y equals 0. It has a root at just one place. This had a root twice. This one has a root just once. And I can find out where that is. Well, shall I try the same thing of factoring? Shall I factor this guy? So I see x squared minus 2x plus 1. Maybe that might jump to mind as it's something times itself. That's a very special one to factor. That's x minus 1 times x minus 1. What I would call a double root. That is 0 at x equal 1. So what am I saying about this guy? Double root 1 and 1. Double roots get mathematicians excited. Well, mathematicians are easily excited, you could say. And that's special. Okay. So it's x minus 1 squared. And we see a double root. Now let me go on to the top guy. Where is that 0? Can we factor that? We have a problem, this one, because we can see from the picture that this thing never hits 0. So am I going to say no roots for the third guy? No roots? I don't like to say that. Gauss, who was the greatest mathematician of all time, said that if we have a quadratic, it should have 2 roots. If we had x to the 27th, starting our y, there should be 27 roots. But where are they? Okay, and if you might say, well, just factor and find them. Well, of course, I can see from the picture I'm not going to find them. If I try to factor this in this way or this way, I don't succeed. What's up here? What's up with this case where the quadratic is up there? So let me pause here and give you a chance to think what to do. See what the problem is. Maybe think of another example. Let me suggest some other examples, some different A, B, and C. Suppose I take A to be minus 1. That will change the picture completely. With that minus sign, my quadratic is going to go downwards. It'll be like throwing a ball in the air and having it come down. It's going to go that way. And let me take, say, 4x here. And I don't know what to take as C. Let me take 9. That seems a pretty big number. I don't know if that has any roots. I don't know if you could graph it, but you could sure try. So have a try, and then I'll see you in a minute. Okay, hi again. I'm back and still looking for those missing roots. You remember we had this example of x squared minus 2x plus 2. So that was a particular choice of A was 1, B was minus 2, C was plus 2. And we couldn't see the roots and our picture didn't show any. And the reason is we're going to have to go to imaginary numbers. I like to think that root is still there. But it isn't going to be, those 2 roots are still there. But they aren't going to be real roots. In fact, I'm going to have to write down the formula that everybody hates. It's the formula for the roots of this thing. I'm going to, roots, you remember, I set this to 0, and I look for x. And I'm going to find 2 x's, 2 roots, where this thing comes to 0. And I'm going to stay with algebra for a minute and write the answer in terms of A and B and C. Because if I know those three numbers, then I've got the quadratic, I've got a picture, I've got the roots. Only either I've got them or they're somehow imaginary. But here's the formula for the two roots. Okay, so the roots are x equal. Okay. There's a minus b, no problem. There's a plus or a minus. That's why I'm going to get 2, because I can take the plus answer or the minus answer. And then I have a square root of, it's going to involve all of a, b, and c in the special form b squared minus 4ac. And then I have to remember to divide by 2a. All right. Sorry about that. Can't be helped. So that, you see, A, B, and C are appearing here. Oh, well, let's just check it. Let's check it on the ones that worked. So this was the case when A was 1, B was minus 2, and C was 0, right? Can I try this formula? Maybe over here, where I'm hoping to get this answer 0 and 2. Let's just see if I do. It's satisfying to think that, okay, this formula works. The B is minus 2, and there's no C. The C is 0. So I'm going to put, there's my A, B, and C, and for practice, I'm going to put them into this formula and see what I get. Hopefully, I get these roots. All right, let's do it. This is my x. Remember what we're finding. We're finding the x is where the curve hits the x-axis, hits 0. Okay, so minus, b is minus 2. Minus 2 is, x is 2, right? Minus 2. Plus or minus, now comes the little dodgy part. B squared, that's minus 2 squared is 4. And I divide by 2a. A was 1. You see how they all come in? 2. And what do I get then? This is from my big formula. I put in the numbers. Now the square root of 4 is 2. So I have two possibilities here. 2 minus 2, which would be 0. Or 2 plus 2, square root of 4, 2, would be 4 divided by 2. I would get 2. And sure enough, that's what I wanted. Formula checked out. The formula checked out to give me those two roots, 0 and 2. Can you do it once more? Well, twice more, actually. Once more, I'm thinking I'm going to get the next one. I think I'm going to get 1 and 1. Let me erase this and do the same thing for the second one, where C is now bumped up to 1. Okay, so again, I have minus B, that's minus 2, that's the 2, plus or minus the square root of B squared is 4. And now I have minus 4, this is coming in now, minus 4, A is 1, C is 1, minus 4. Huh, it's not bad. Divided by the 2a, which is 2. Okay, I've plugged it in the new ABC with C equal 1 now in there. And what do I have here? This square root is 0. 4 minus 4, that's a very special case. So now I have 2 plus 0 and 2 minus 0. 2 both ways. And then I divide by the 2, so I got 1 twice. Just what I wanted. Just what I wanted. The double root. The double root happens when this square root is a 0. That's when you get the double root, because then the plus and the minus are both plus 0 and minus 0, no difference. All right, third one. This is the new one now. This is the one where we're going to find a root where our picture doesn't show one. Okay, so now what's the deal? C is bumped up to 2 now. Okay, so C is 2, And I go again last time with this formula. All right. But now I'm going to get something I didn't know. So minus b is the minus minus 2, that's the 2, plus or minus the square root of b squared, that's the 4, minus 4ac. Now let's get it right. Minus 4, a is 1, and c is now 2, so that's minus 8. Minus 8 divided by 2a, which is the 2. What have I got now? I've got a square root of a negative number. That's what the problem was. That's why I couldn't see it in the real world, because it's not there in the real world. 4 minus 8 is minus 4, right? So what's the square root of minus 4? What's the square root of minus 1? That's where we're going imaginary. The square root of minus 1, there isn't any real square root of minus 1. So we invent one. I for invent, I for imaginary. So the square root of minus 1, can I write that great fact up here? The square root of minus 1, we're going to say is I. I for imaginary. Now here I've got the square root of minus 4. Well, the square root of the 4 is 2. It's the minus 1 that's making me imaginary. So this for me is 2i. 2 plus or minus 2i divided by 2. Why 2i? Because if I square, what's the square of 2i? Let's just check this out. What is the square of 2i? I squared is minus 1. I can put up here, I squared is minus 1. And 2i squared, so I have the 2 twice, that's the 4. The I squared is the minus 1, it's the minus 4. That's what I wanted. That's why that square root is 2i. Now, I get to cancel the 2's. Can I just do that? 2 divided into 2 gives me the 1. 2 divided into that 2 gives me the 1. Look what I've got. 1 plus or minus I. 2 roots. As we hoped, as Gauss was sure we would find, 1 plus I is a root, 1 minus I is the other root. Neither one is real, but they're both, complex number is what I should say. A complex number is a number that has a real part, the 1, and it has an imaginary part. And here we get an example with both, and it connects to the picture when the curve doesn't actually cross the x-axis, and that's because I only knew how to draw a real picture. Okay, so that's the answer. Those are the missing 2 roots that we were looking for.